Okay, so now we're going to talk about extended ratios. So extended ratios, it's just when you have more than one ratio. So instead of just comparing two things, in this scenario, you're comparing, for example, three things. It can be more than three, though. It can be three or more things. So A is to B and B is to C. Now, what's really cool about this is that not only does the ratio work A is to B, but the ratio also works B is to C, and the ratio also works A is to C. So kind of cool that all three of these ratios all work to have the same ratio. So for example, find the measures. It's not the same exact ratio, but they all work in relation to one another is what I mean to say. All right, so in example 2, find the measures of the angles or sides of each triangle. The ratio of the measures of the angles is 4 is to 5 is to 6. Okay, so think about it for a second. What do you know about all three angles in a triangle? You know that they all three add up to 180 degrees. Okay, and so if they all three sum to 180 degrees, then we know we should add, right? So what would this look like if our smallest angle was 4 something, and this one was compared to that, it was 5 something, and then compared to that, this was 6 something? What does that look like? I'll pause the video for a second and think about it, and then come back and we'll take a look. So when you think about it, when you say a ratio of 4 to 5, let's pretend originally the ratio was 16 to 20, right? How do we go from that reduced fraction back to what it used to be? Well, essentially what I did was I multiplied by something, right? In this case, I multiplied by 5. So if I want to go backwards, let's pretend that it wasn't 16 to 20. Let's pretend that it was 24 to 30. You're multiplying by some number, right? We just don't know what that number is. We just know what it was as a reduced fraction. So essentially 4 times some number, we'll call it x, 5 times some number x, and 6 times that same number x would give us what the original numbers were, the degrees of those original numbers. Ooh, and then from there, we know that all three of those numbers had to initially add up to 180 before we reduce them. So we know that 4x plus 5x plus 6x adds up to 180 degrees, right? And so we have 9 plus 6, that's what, 15x equals 180. Divide by 15 on both sides, and we get x equals 12. So 12 is not our answer, though. It said find the measures of the angles or sides of each triangle. We're looking for what were those angles originally. So if I want to go back and figure out what they were originally, well, I do 4 times 12, plug it back in, 5 times 12, and 6 times 12. So 4 times 12 is what? 48. 5 times 12 is 60, and 6 times 12 is 72 degrees. And there's my original three measures of this triangle. Okay, so let's try another one. At the top of the next page, you have the ratio of the measures. This time it's sides, folks. So this time we're not thinking about how much angles add up to. We're thinking about how much sides add up to. Now, lucky for us, sides, they told us the perimeter is 104. That's what they add up to, right? So we're talking about 3x for this side, 4x for this side, and 6x for the hypotenuse. So here we go, 3x plus 4x plus 6x all adds up to the perimeter of what, 104? Okay, so we're going to add those like terms. 7 and 6 is 13x equals 104. Divide by 13, and x equals 8. But wait, there's more. We got to plug it back in because it was asking for what is the actual side length. So we're going to say 3 times 8, 4 times 8, and 6 times 8. So 3 times 8 gives us 24. 4 times 8 is 32. And 6 times 8 is 48 for our final answer. Ready? You try. So pause the video, try it on your own. We'll come back and check. Okay, so I hope you made that 7x plus 9x plus 12x equals 84, in which case your equation came out to x equals 3. You plugged them back in. 7 times 3, 9 times 3, 12 times 3. So your three answers were 21, 27, and 36. So I hope you got that. All right, a little bit more exciting this time. We're going to step it up a notch. Perimeter of a rectangle, we're no longer dealing with triangles, friends, is 220 total. The ratio of the length to width is 7:3. Find the area. All right, we're gonna pause on finding the area. We're just gonna focus on number 1. The ratio of the length to width is 7:3. So length we're gonna say is the long side. Width we're gonna say is the short side. And so let's think about this for a second. If this is 7x and this is 3x, to find perimeter of a rectangle, it's different than finding perimeter of a triangle, right? Because 2 of the sides are the same. So we're going to have 2 sides of 7x plus 2 sides of 3x for a total perimeter of 220. Right? So that gives us 14x plus 6x adds up to 220. So 20x equals 220. Or x equals 11. Okay, but what the question asked for, now let's transition to part 2. Now that we know that x is 11, this side has to be 7 times 11 or 77 in length, and this side has to be 3 times 11 or 33 in length. So when I go to find area, remember area for a rectangle is length times width, right? So I'm saying 33 times 77, which gives me 2,541 for the area. So that would be, I'm going to say U stands for units squared. So, all right, so you try, pause the video, try this one on your own, and we'll come back and check it. Okay, this time you weren't adding them up to a perimeter. You had 2 angles that were supplementary. So I hope you added the 5x plus the 7x to 180. In which case you got x equals 15. You plug that 15 back in. 5 times 15 was 75. 7 times 15 was 105. All right, we're going to end this video and we'll start again at the next one.